Wow, this video just seriously does not want to happen. So let me tell you what's been going on. I recorded the first run through of this video and I had my mic turned off, and then I recorded the second run through, which was much better, and I didn't have record pressed. So I've just done like almost an hour of work, just double checking I've definitely got the record button pressed, and my mic is definitely bouncing up and down. Oh, okay, so I think we're here. I think this is now, I've just recorded so much I don't know what's going on anymore. This is the second camera video, so I'm going to be straight up with you. I did a bit of work on this offline. I was kind of a little bit bored waiting for time to do another video, so I got this up on my laptop. I had a couple of nights where I couldn't get to sleep, so I set up and did some tweaking. It's not perfect, but we've pretty much got the RTS-style camera going. So what I'm going to do is let's pop open Unity. So first up, we've got our camera. This has a script called follower script. This has a goal position, a goal speed, which is a floating point, follow speed, a float rotation speed, a float zoom, a float max zoom. We've got this vector free center offset, and we've got rotation. So the goal is what we're looking at. The rotation is, let's do this in order. The goal is what we're looking at. The goal speed is how fast the goal moves when you press down keys. The follow speed is how fast the camera moves to smoothly follow those stepped goals, right? Because we're updating the goal in fixed update, and then we're updating the camera position and orientation every frame based on that goal using linear interpolation. Doesn't quite work, and we're going to go into why. We've got the rotation speed, which is how fast the camera rotates around the goal position. We've got the zoom, which is the current zoom level from the goal, so that takes us up high and down low, right? Our max zoom is the maximum distance we want to be. The camera offset is, I know it says 0, 0, 0 down here. This should actually be 0, 0, 5. That is where the camera is relative to the goal, like its fixed position, right? And then that basically means that when we're zoomed right in, we're not sitting right on top of the goal, we're like back 5 units from the goal. And then zooming is based on that to zoom the camera up and down, yeah. And then rotation is our actual rotation in degrees. Oops. Is our actual rotation in degrees around the goal, and we're using that. We're basically rotating center offset by that to get our position. Okay, so one thing I did a couple of little bits while I was recording, well, not recording as it turns out. I think I might have nerfed the rotation. Yes, I've nerfed the rotation, but WASD moves the camera around, right? The red dot is just a gizmo to show us where the center is. Control and Shift zoom in and out, and you get this nice swooping effect. And then Q and E don't rotate at the moment, because while trying to do something else during the last recording, I think I've nerfed it. So if we go into Visual Studio, we've got, those are the things I've just gone through, right? I should probably comment these for my own notes, but here I was hard setting that center offset, or I was setting up that center offset to be 5 units back on the Z-axis. I think in the editor I just set it to, yeah, that needs to be -5. Let's do that. Whoops, that one. Definitely still recording. Yep, good. So what I was just doing in the video was I was going through some changes to this update function. So update runs every frame, right? Every single frame. And what I was doing is I just modified this because I wanted to pre-calculate this and make some changes. So what we're doing is we're setting our scaled center offset to this constant center offset value. Yeah. We're then setting the Y value of that equal to zoom squared, so that we've got like the nice exponential zooming thing. And then we're setting the scaled center offset to multiplied by zoom, right? And that gets us our nice kind of backing out swooping. What I hadn't done here is I actually want to then scale center offset dot rotate around Y by rotation. Cool. Now that's going to look a bit weird because rotate Y, rotate X, and rotate Z aren't actually real functions in the Unity vector free class. We're going to come on to that because what we need to do is expand what vector free can do, what any of the vectors can do, and that's my first little thing that I've added to it to expand it. Right, so now if I go back here, if I run again, we've now still not got rotation. Yeah, so that's interesting. Alright, we want to do that first and then we want to rotate. Let me do this. Vector free extensions, these are the ones I actually tested. I know what's wrong. Yep. This rotate Y returns a thing, it doesn't actually rotate the vector in place. A little bit embarrassing, I only wrote this like 2 days ago. I only wrote that function 2 days ago. I should remember what the thing is. In fact, actually, yeah. Yeah. It's an extension method, it returns a vector free and it takes in a floating point angle. Yeah, I should have just known that. Anyway, so that should work. Ugh. Keep doing that. That is driving me mad. I've got the Visual Studio tools installed as well, so I'm wondering whether that should press debug in Visual Studio. It should run this, right? I don't know. So we've still got Y-side control, we've still got zoom, and as you saw I accidentally hit the rotate, we've still got rotate. And now what we've got, which we didn't have last week, is it moves, if I press the W key, it moves in the direction of that. Yeah, cool. Okay, so we got that. So the only other thing I've wanted to mention that I've added is I've got a little GUI panel up here with free orbit and chase buttons. These don't do anything. What I'll do is probably do a separate video where we recreate this and wire it up. I just wanted to play around a bit to see if it worked. So that's basically where we are. So let's go through the code. So right, we had a quick look at our update. What we've got here is we're working out relative to goal where the camera needs to be as far as zoomed out from goal and rotated around goal is, yeah? So we've recalculated our offset. Then what we're doing is we're setting our camera position to lerp, or linearly interpolate, between its current position and the goal plus the scaled center offset, which we've just calculated. And we're doing that with a factor of 1, which means it will always go straight to the goal, right? No, the reason we're doing this is because if you don't do this, this is a problem that I had with the code. If I put that back in, you'll see one of the problems that I've not managed to fix. So you can see that like swinging effect? That is really weird, right? Now what's happening there is we're rotating the camera to look at the goal. And what's happening is because we're linearly interpolating, we're moving the goal in chunks, right? like big steps every time fixed update runs, and then we're smoothing the movement of the camera afterwards. But what's happening is the goal moves in steps and the camera steps to follow it when it's like looking, but then the movement catches up slowly. So whereas the transform position has an easing effect on it, the transform look at doesn't. So this snaps to look straight at it, and then the camera slowly catches up, which means it kind of twists around and follows it weirdly. That's on my list of things to fix, but I've not got around to fixing it yet. So that's probably, I'm going to do a couple of goes through this. I'm going to do setting up the basic functionality like we have now on all of the camera modes. I'm going to go through and make them nicer. I had this to do. Do I actually want to multiply by zoom here? No, I didn't, and in the previous attempt of recording this video I fixed that. So we're basically setting our scaled center offset, which is a variable, to center offset. We're then multiplying y by zoom squared. Sorry, we're setting y to zoom squared. We're then setting the center offset, which is 5, multiplying it by zoom so that it will pull back as it pulls back along z as it zooms up. And then we're rotating this whole combined thing around y by rotation value. So we've got that. So this is our update, and this runs every frame. And then we've got fixed update, which runs whenever it needs to frame, right? Whenever it has the ability. I'm a little bit fuzzy on when fixed update runs, and I've got a to-do later on down here to say look that up, because I'm using time.delta time in this function, and I don't know what that means, right? Does time.delta time should mean the time since the last frame, right? But fixed update runs every sometimes frames, right? So I don't think that in the context of fixed update, I don't think that delta time means what doesn't mean anything, right? It just means the time it took to draw the last thing. It doesn't mean that the time since the last fixed update, which is what I wanted it to mean. Yeah, so there's a few little problems in this. Anyway, so what I've done is I've gone through and I've left all of my code commented out. And if I comment it back in, we can talk through what we've had since I did the last kind of live video. So basically, where we left it in the last video, I had definitely still recording. I'm gonna be doing this forever now. In the last video, we had it moving. It goes north, south, east, and west. Yeah. And we're doing that by adding the vector free right, vector free left, vector free forward, and vector free backwards to the goal. Right. Now those are in world space, so they are literally the equivalent of north, south, east, and west in world space, which works great if the camera doesn't rotate, right? If you're not rotating the camera around to face south, then this is fine. Excuse me, my stomach just gurgled a bit there. So yeah, if we're not rotating the camera around to face south, then this type of movement is fine. And if you had like, I don't know, an isometric or a top-down view game where the camera is always at fixed rotation, this would be perfect, yeah? However, because we're rotating the camera, we can get the situation where you've rotated the camera to face south, yeah? Now when you press W to move the camera forward, what you are expecting it to do is move south, to move along the screen, right? Yeah? What it'll actually do is it will move north, which will move backwards from your perspective looking south, right? Which is all confusing, right? So this doesn't work if you've got rotation on the camera. Because we have rotation on the camera, this is not good for us. So comment it out. I left it in there so I could show you guys. And you can see I've gone through a few iterations. So that, I've got the note here, works in world space, north, south, east, and west, right? So then I've got this approach which works in local space. However, what this does is the WAS and D keys move the camera transform along its forward and right axes, yeah? So if I... Oops. Extra commented for security. So what we're doing here is we're setting the current position the goal equal to the current position plus the camera transform's right value, right? So what that will do is, if you can imagine the camera, right, you've got that's the forward transform, like looking down the lens of the camera, yeah? I'm just trying to think if I actually got a camera I can demonstrate this with. I do. Right, so what we're doing is forward is straight out of the lens, yeah? And right is out the side of the camera. So what we're doing is when we're adding right to the position, we're moving it that way, yeah? And when we're adding forward to the position, we're moving it that way. Which is great, because, you know, at least have it the right way up. So that works great, but when you rotate the camera down to face the goal, you've then got the problem that if you move it forward by pressing the W key, you're not moving it like that. You're actually moving it like that, down the forward direction, which is straight out the lens, yeah? So this kind of works. It kind of got us a little bit closer, but it still doesn't do what we want, right? Because when you zoom out, look down, you want to move forward. You want to move forward along the level. You don't want to move forward down into the ground, right? So close but no cigar. Okay, which gets us onto this, which is my final approach on this one. It could do with some cleaning up, but right now it's okay. You see I've got my note to check out how delta time works. So what we're actually doing here is we are calculating constrained forward and constrained right. And these were two private variables I had up the top, and at this point I can't remember if I discussed those. I think I discussed those in the previous video. We've got these, pre-allocating some vector frees for constrained forward and constrained right. Where are we? So what we're doing is we're calculating these. And we're using this vector free extensions class, which is a static class which contains cool little add-ons for the vector free thing. So I wrote that while I was doing this, and I'm going to continue adding to this as we go. And extending classes is a great aspect of object-oriented languages like C#. So what I've got is this has some static methods called rotate around axis, right? And they take in a vector free to rotate and the angle to rotate them. And the way we're doing this is we want constrained forward to be, if the camera's like that, we want constrained forward to move along. So we want the movement to be stuck to the XZ plane, yeah? So what we're doing is we're just getting the Y angle, right? And this caused me a lot of trouble. So for about an hour I was mucking around with this, and you probably noticed that I've been asking people on Facebook in like the kind of the developer groups, and then feeling really stupid afterwards that I was thinking that how I was calculating inside this function was wrong, right? What I was doing is I was using rotation Y. Rotation is a quaternion, and Y is, I don't know how quaternions work, but that is not the rotation on the Y-axis. That is some matrix part that causes quaternions when you put a number in to get the right rotation out. So rotation.y, rotation.x, rotation.z, and rotation.w are not the x, y, and z rotations, right? This had me going for ages. So what you need to do is you need to use the Euler angles, I think that's how you pronounce it, which converts it into a like rotation around axis, yeah? And the advantage of using quaternions rather than a vector free to store the rotation is the quaternions are like kind of a matrix structure for rotating things, I think, and they don't have the problem of gimbal lock, in that you can rotate everything around. You're never going to get the situation where your x, y, and z axis all line up together, so that if you rotate x and z at the same time, they'll all rotate in the same axis. That's not possible to do with a quaternion. It is possible to do with an Euler angle, and that can cause problems, and in like games that I've worked on in the past, that has caused problems. So that's something you need to kind of pay attention to when you're doing stuff with the transform rotation, is it's not how you think it was. If I'd read the documentation properly, I probably wouldn't be having this conversation, but you know. Anyway, so we're taking, back to what we're actually doing here rather than asides. We're taking this y-axis, right, which is the actual rotation around the y-axis, right, of the camera. So that's taking into account how we're facing, yeah? And then we're rotating around y vector 3 forward. So this is a world space 1, it's 0 on both axes and 1 on the forward axis, yeah? And then we're rotating it around the y direction so that we now have a rotated vector along the xz plane that's facing the right angle, yeah? And that's our constrained forward. So we've now got the equivalent of this transform forward, but it's been flattened out onto the xz plane. We're doing the same with right, and we're doing exactly the same approach. We're just rotating the vector 3 right, constant one. So that now gets us a forward direction and a right direction that's constrained along the xz plane. And then what we're doing is we're doing the same again. We are now, in this case, when you press the A key, we are making goal equal to its current value minus the constrained right value up here, right? So, I should probably mention this is still a normalized vector in that it still has a length of 1, so we can always be happy that these have a length of 1, right, without having to call normalized, because we've just taken this, which is a normalized vector length of 1, and rotated it around, so it will still have the same length. So we don't have to worry about normalizing things here because these are already normalized the way we created them. We're then multiplying it by the goal speed and by the zoom and by delta time. Delta time, obviously, as I mentioned a minute ago, I now have like reservations about whether I should be using that here or not. And zoom is we're multiplying it by zoom so that the further away the camera is from the goal, the faster the goal will move. Because what will happen is you can zoom out really far, and then when you're moving the camera, it doesn't look like it's moving at all because it's only moving a few units a second, right? So it's moving a distance that's not even visible at the sort of the height the camera's at. So what we actually want to do is we want to move that exponentially faster. Sorry, not exponentially faster, but we want to move it faster as the zoom goes out, so that when you're zooming right out, you can still move around at a useful speed. And you can zoom out and traverse large distances with the camera and then zoom back in. Is kind of the way that I envision that being used. So we've basically got the same for all of those, and that's how we're moving the camera around on X and Y. So then we're getting on to zooming, and currently I've got these bound to the left shift and the left control keys, just because my laptop doesn't have a mouse wheel. But eventually this will be the mouse wheel basically. And what we're doing is, if our Y position of the camera is below maximum zoom height, then we're multiplying zoom by 1.1, which basically adds 10% more to the zoom. And we're doing this so that as you zoom out, the further you zoom out, the faster it zooms out, so that you're not constantly like scrolling for ages to get higher and higher with the camera. One click on the mouse wheel will take you to 10, 2 clicks will take you to 11, 22, maths failure. Yeah. Anyway, it will keep going faster and faster as you zoom out. This could probably also be like a variable or a constant in this function. Right now it's not. And the same with left control, we're multiplying it by 0.9, which makes it 90% of its current value, so it subtracts 10% of the current zoom height from the zoom. And you saw up in update, that's, yeah, as you saw up in update, that's how we're doing that. So then finally we've got rotation, which is pretty boring. My only note on this is that could probably, I could just multiply rotation speed by 10, which is probably what I'll do. So if I just delete those, what we're doing, you hold down Q, it adds to the rotation, you hold down E and it subtracts from the rotation. So that's fairly simple. And again, up in update, that's actually used to work out the current orientation of the camera. So if I go down here or up there and make that equal to 50, then that's that little mess fixed. And then finally, go back down, we've got the rotation. Finally, we have this When you press the space bar, it resets the camera to 0, 0, 0, and zoom level of 1 and rotation of 0. So it resets all of the values of the camera. That's nice and useful for debugging because it was a mess otherwise, right? As you saw in the last video where I had some problems with the camera with the goal tracking, you press W and it shoots off into infinity, and then you need to restart the program to get the camera back. Just being able to press space and resetting things is a nice way of doing that. Okay. So then finally, the only thing else we've got in here is on draw gizmos. Excuse me. Which is used to draw the little red ball in the scene view. We're just drawing a 0.5 size sphere in scene view, just so we know where the goal, the centre of the camera is, or the goal position of the camera is. So that's all I was doing. You can see I've got some little bits of debug information in there as well. So that's that. What we want to do is, I need to go over the vector 3 stuff. So this is pretty cool, and I'm zooming out on the wrong screen. So what we got is I've made a static class vector 3 extensions, right? So it's a static class, you can't instantiate it, you can't make a vector 3 extensions object from this class. It's just a kind of a box to hold methods in, right? And then we've got static methods. So everything in this class is static. We've got static methods that belong to vector 3 extensions, which are the ones I just showed you using. Or I think I've used both of them in the code. We've got rotate around X, rotate around Y, and rotate around Z, and these take in a vector 3 and a float angle to rotate, and they return a vector 3 that has been rotated around that. And the entire point of these is just to save me making mistakes writing out that every time. Yeah. So what these actually do is they create a new quaternion, which is created using this quaternion angle axis, which takes in an axis and a vector to rotate around, right? And then it multiplies that quaternion, which is basically like a rotation transform matrix. I'm using that term really loosely. I don't actually think it's a matrix, or it might be a matrix, I'm not sure. Let me just move that because I'm looking at my view. There we go. No. So I think that's a rotation matrix. I'm not 100% sure under the hood how quaternions work. I've got some maths textbooks, I should probably go and look it up. Anyway, basically that creates a way to transform a vector, yeah, by rotating around that angle. And then when you call the multiply operator is they've got an overloaded operator on the multiply, so it doesn't like literally rotate multiply the values in the quaternion by the values in the vector. What it does is it transforms this vector by that quaternion and returns a new vector. So that doesn't actually multiply, it's just they've overloaded it to like to be to allow you to transform things. So it's like they've used it as a function or a method rather than a thing. Operator overloading, I've very rarely done it. I'm trying to think, have I never done it? I don't think I have ever overloaded an operator in one of my own classes. Well, we're probably going to be writing a polar 3 and a polar 2 polar coordinate equivalent of a vector, which is probably going to need that because we're going to want to multiply them together. That's going to be an interesting exercise. Anyway, so these are static members of vector 3 extensions. So you can basically call these as vector 3 extensions dots rotate around Y, vector 3 up 10, right? So that will rotate that up vector around Y by 10 degrees, which will give you nothing. You'll get exactly the same vector back out again because it's rotated around its own axis, right? So that's how we use that. And then slightly more fun, which might be more interesting or more useful for people, is we've got these. So rotate X, rotate Y, and rotate Z, right? And these, the first parameter is this vector 3, right? Now this is really cool because when you call rotate X, in fact if I do this, that's how we use this. Cool? Yeah? Is that cool? It's definitely cool, right? Well, I'm cool, dudes. What this vector3 first parameter says is that's what we're attaching it to. We are gluing that function onto that, yeah? So now when you call vector3 up, right? Vector3 up is creating us a new vector3, yeah? Right? Let's actually do this longhand so I can just show you. Right, so you create a new vector3, yeah? So now, because we've got an object, we have these rotate x, rotate y, and rotate z functions, yeah? Because even though these aren't actually part of the Unity's own vector3 code, because we've like glued them on the back, this is a process called extension, extension methods. We now have the ability to call rotate z on this, say, and voila, we've added a new functionality to the existing vector3 class. So I've used both of these approaches in the follow controller, but this is basically the reason I've done this is because that is a bit of a pain to write out, and it's a place where I could make a mistake, right? When I'm thinking about this, what I don't want to be thinking is vector3 right that axis or that axis or what? What do I want? I really wanted to just say rotate around x, please. Right, that's what I wanted. So I've made this once, I've tested it, I'm happy that it works, and then I can now forevermore use vector, my vector dot rotate x and give it an angle, and I'm happy that that's gonna give me everything that I want. Yeah, okay, so that's pretty much where I'm at the moment. What I'm going to do is I'm going to see if I can edit these down a little bit. The time that I was going to do extra work with, I've spent faffing around with the recording. If anyone has any questions, stick them in the Facebook group or stick them in the comments below. I'd be really interested in that. It's obviously early days for this project. I'm interested to see what people think with the format of the videos. Are they too long? Are they too short? I suspect they're probably going to be a little bit long. I'm probably aiming around 30 minutes per video at the moment, but I'm not 100% sure on that. I'll have to see what footage I've got. Anyway, brilliant. Thanks for watching, guys, and I'll see you in the next video. See ya. Bye.